Hello everybody, welcome back to the Engineers Team 9892 Coding Bootcamp for FTC. In today's video, we're going to be talking about camera detection and OpenCV and color detection, how to do that. So in the previous video, we talked about basic encoders, which is very nice, but in most of FTC's games, we are going to have to detect something and go to that position. So what we're going to do today is we're going to create a camera example and OpenCV pipeline. As you can see, I already created them. So in this video, I'm just going to be explaining them. And if you do want to copy them and like write them down or like just type them all in while I'm explaining, you can. Or this GitHub will be in the description. So you can also just copy the files as well. That would probably be the easiest way. But without further ado, let's begin. So what is OpenCV and why do we need it? OpenCV is a color detection orientated program using cameras. So we use a YCRCV detection, and I'll get more into that later, but basically it detects blue and red, which is very useful for us. So this year's game, Center Stage, we need to detect a blue object and a red object. Now, for this year's game, we need to have two pipelines. In this example, I'm only going to use one. But we basically need to detect a blue object, so we'll have one pipeline that detects blue and one pipeline that detects red. And we're going to use these pipelines for our camera code as well. So, first things we need to do is we need to fix or adjust the Gradle a little bit. So we need to add this line of code here, implementation, or not comma, but like single quote, org.openftc easy open ftc 1.7.0. And basically all this is just, hey, this is the newest FTC version for Easy OpenCV, and we will need this because otherwise we will get a lot of errors in our code. I'm going to give you guys a second to do that. Okay. Now we're going to go to the Easy OpenCV pipeline. Now, this is going to be a lot of information. Now, basically what a pipeline does is it gathers its own information and stores that data. So what we'll be doing is in our main code here, our camera example, we're going to be pulling this data and using it in here. And I'll explain what that looks like in a minute. But like we would need so again, this is the basic package. So where the file is located, the file directory is located. You have your import.qualcomm, your linear out mode, your teleop. And honestly, I would add disabled as well. I would do an @disabled here. Just because you're not going to ever use this as an op mode in driver control. So you can just disable it so the drivers don't see it and accidentally misclick. Then all of this here, I'm going to pause for a minute, is all OpenCV stuff that you need in your pipeline. You will absolutely need this. Otherwise, your code will not work. So I'm going to give you guys a second, either if you're writing this, to type this all in. But basically, it talks about matrices, points, rectangles, scalars, image proc, cameras, camera factories, camera rotation, pipelines, webcams, the actual hardware for the webcam, the internal stuff for it, and all that jazz. So let's move on here. Again, we've seen this a million times. Our disable teleop public class, whatever we named our file, extends linear out mode. And then we're calling the webcam. OpenCV webcam is how we're going to call our webcam. And OpenCV pipeline is how we're going to call the pipeline. This right here is going to give you an error right now if you are typing this manually. Because if you scroll down to here, we called it public static class OpenCV pipeline extends OpenCV pipeline. The reason why, if you change this, you're not going to, this right here is calling this. So unless you write all of this information here, you're not going to be able to make this singular line. So do not worry if you're getting error if you're typing it, but just keep that in the back of your mind when writing this. Otherwise, you can just copy this file and move on. Again, you're at override, and this is your run op mode. So again, you're initializing the camera. And I'm just going to slowly go over this real quick. Int camera view ID hardware map.app context.get resource .get identifier quotation marks camera view ID quote ID hardware map.app context.get package name. All it's saying is, hey, this is a camera monitor view ID. So if you're not, so before you hit play in an op mode, you can actually view what the camera is looking like. That's all this is saying. And again, this is the hardware map for the webcam, and we just call it webcam 1. You can call it whatever you want. We just try to keep it consistent at least. And again, this pipeline equals new OpenCV pipeline. Just has to be consistent with this name up here. And then the webcam.set pipeline. So again, this gets used here. And then now we're going to go to here. So now it's rendering this the webcam is now rendering what it's seeing. So again, webcam.set view port rendering policy OpenCV camera view rendering policy optimize view. Basically, all it's saying is, hey, I'm rendering what I'm seeing. Now we're going to go down a little bit more, and this is basically when the webcam is open, and this is all it's going to see. So we run a 1280 720 camera. So if you run a different webcam, you're going to have to change these dimensions, and this is the way we normally look at it. And normally we run upright. This is normally the way you would run your camera, is when it's facing upright. If you do have to change it, like you put it on its side, you will have to change this right here. But basically what it's saying is on open. So if you hit initialize and you say view webcam stream or whatever it's called, you view web stream and then you see what the camera is seeing. It's going to start streaming the webcam at this view. And then on error, it's going to give you an error if it couldn't open. And it will give you a massive error, blah, blah, blah. And that's basically what all this is saying. And again, just as a reminder, feel free to pause so you can look at the code. There are comments here, so if I don't fully explain something, please feel free to look at it. Again, this is just the wait for start. And then while op mode is active, it just says the analysis, pipeline.get analysis, so what the pipeline is seeing. And then it's just giving the telemetry of it. Now, this is where the pipeline needs to be created. And to be perfectly honest, before we get into this, camera detection is not my strong suit. So I will do my best to explain it, but I'm not 100% accurate on everything here. So without further ado, let's get into this. So these right here will be your detections used in OpenCV camera example. Pretty basic. And used a little bit throughout this code, not very much, but these are mainly used in this right here, and you'll see why in a minute. I'll come back to this later. If we scroll down, these are the colors to make the rectangle. So the camera is split up into 3 sections, and you'll see this down here. It creates it into one massive box, and you'll be creating 3 different rectangles. The reason why is you'll be splitting up the boxes, or splitting up the sections that you want to detect into 3 different sections. Because of this, we'll be creating rectangles using green rectangles when we're viewing the live stream, just so we can see it a little more clearly and a little more visibly as well. And these are just anchor points so we can actually properly detect on where those at. So we set these here. These seem pretty fitting for our webcam. You might have to change it for yours. Again, the region width and the region height might also vary. And again, all of what this is saying, region point A, point B, point 2A, or 2A, 2B, 3B, 3A, is basically saying, hey, this is our box, pretty much, and where we need to place it. That's all what all this is just saying, and how to calculate it. Now let's talk a little bit about the matrices and what YCRCB is. What is YCRCB? I'm going to have to go here. I'm going to go to here. So YCRCB is a luminosity, chroma red, and chroma blue. So if you're detecting chroma red, you're going to want the most amount possible, like the lightest colors. So like if I'm detecting red, right, I'm going to want the minimum amount of chroma red possible. So I don't want to detect green. If I'm detecting blue, I want to detect the most amount of blue possible, right? So the max amount. And basically all this is saying, L is just luminosity, so the light of it, like how bright the color is. So yellow, you can see here, is the like brightest color there is. So you want a high luminosity. Very similar to like white up here. White has the highest luminosity because it brings off the brightest color. Chroma red is just the red color, which is A, and then B is just chroma blue. Just keep that in mind when we're talking about this. This sheet is very useful, and I highly recommend using this as a reference point throughout trying to code your YCRCB stuff. I really do recommend it. But I'm going to get back to the coding now. So if we go back to here, we create a matrix for region 1 chroma blue, region 2 chroma blue, region 3 chroma blue. And in this scenario, we're just detecting blue. It makes it a little bit easier. And feel free to adjust this to however you like. We're creating a new matrix for YCRCB and a new matrix for specifically chroma blue in this scenario. And we also create a variables, average 1, average 2, of average 3, and we will eventually use this to detect the averages of all 3 boxes and detect the most amount of like blue in an area or most amount of red in an area, depending on what you're looking for. This basically all it's saying is the default position is also the left position, just as a heads up. So input to CB, so input to the matrix. So it's saying, hey, input the color detection. So we're using YCRCB. This variable up here, the matrix, we're using the color. And what all this is saying is, hey, we're using YCRCB. And then the extract channel is basically the matrix, the other matrix, and then the color of interest. So we're using like the color of interest. So it's like, oh, we're looking for red. Let's detect red, blah, blah, blah. So on and so forth. We're going to go down here. So I override init matrix first frame. And basically, this is talking about the matrices. So it's like where to detect the most, like the averages of where to detect the colors. This is where they detected. So all the way back here when we created all this stuff up here, it detects it all in here, which is why we created this up here. And that's why we're using it now. So this right here is very useful for that. And then we created our own for here, our matrix. So, and again, keep in mind, some of this you might have an issue with if you don't create the, what's it called? The functions for it. But in this case, because like we didn't create mat originally, we might have an issue with that. Let's see up here how mat isn't created. So now input to CB. Now we have to average the colors. And then all this is just averaging what's inside the rectangles and creating like a massive green box above it saying, hey, this is a color that was detected, guys. And then here is saying, hey, this is, I want to find the max of it, or I want to find the minimum of what. So if you're detecting chroma blue, detect the minimum of it. If we're detecting chroma red, detect the max of it, and so on and so forth. So depends on what you're detecting, but like if we're detecting chroma blue, we want the max of it, so we want the darkest color. If we're detecting red, we want the a lighter color, so minimum in chroma blue situation. And again, it's just detecting the average. That's what this is. All this here, and then this right here, the detection positions, is just saying, hey, this is the positions on where it's at. And you just need this so it gives back the information. And that's the pipeline. So we're almost done. Now we have to go to the OpenCV camera example. Now this is a little more where it matters. This is where it mainly matters, just because otherwise this will not function properly. So let's talk a little bit about this. This refers off the OpenCV pipeline. OpenCV webcam, same stuff as up here. If you really want to, you can just copy and paste this and paste it in here. It's not that difficult. The OpenCV pipeline, OpenCV pipeline. So what it's doing is just calling this pipeline into here. And same thing with this. OpenCV pipeline dot directions underscore positions snapshot analysis. All it's doing is at the very bottom, this line right here, is it's just talking about this. It's saying, hey, where did I get my information from? Why did I get my information from this? And again, it's just saying, hey, the default is left. It's saying the default is left no matter what. Then this is how you initialize everything. I'm not going to explain this. It's basically camera view ID hardware map, webcam hardware map, pipeline, and webcam pipeline. And then this is the seeing it before initialization. Because again, I've kind of explained this already in the OpenCV pipeline already, so feel free to just look at that. And then while not stop and start as requested, do this. Basically what this is saying, hey, in initialization, do all this information. So basically, hey, real-time analysis, so check what it is before you hit play and constantly make adjustments. So see what it is. And it's basically changing about every 50 milliseconds or so. And again, I wouldn't suggest changing any of this. This is what it's. I would just keep it the way it is. Now, this is the main thing that you need. Switch snapshot analysis. So if you remember back up here when I talked about the left, right, center detection positions, this is where it's used. It's used in your main autonomous. So I'm kind of using this as an example. It's like motor FL dot set power 0.8, and then the middle, the right case didn't do anything, but the middle had it to 0.2. Theoretically, and I know it's an error, don't worry about this, it's just an example. What this is saying is if it's in the left position, it's setting the front left motor to 0.8, but if it's in the center position, it's setting to 0.2. If right, it doesn't do anything. That's why we need it the way it is. Otherwise, it detects the specific boxes and where it's at. So if we detect it in the left position, it does a specific thing. The right position, a specific thing. And the center position, a specific thing. Now you can kind of rearrange this to whatever you like, but again, it doesn't really matter. You just need this specific thing to run your autonomous. based off of the OpenCV pipeline. And with that, that's going to conclude our episode on OpenCV. I hope this was useful. There are some tutorials. There's one that I will be linking. It's called Skystone Determination Example. That is basically what we based our code off of. But I try to give a little more explanation and a little more in-depth learning on how to do OpenCV itself. And with that, that's going to conclude our video, and I hope you guys enjoyed. Thank you guys very much for watching. I'll see you next time.